All right. Well, thank you for joining us today. Again, my name is Mia Stevens, and I am a member of the JMP academic team. And today's webinar is Teaching Predictive Modeling with JMP Pro. We are currently on JMP 13, so our current release of JMP is JMP Pro 13. So if you were with an academic institution, JMP 13 came out in September, and the maintenance release, JMP 13.1, was released a couple of weeks ago. If you need to update, if you go to Preferences in JMP, there is a JMP Updates button where you can check for updates. Now, I'll be using JMP Pro throughout this webinar, although some of the features that we'll talk about are native to JMP. If you'd like to see the differences between JMP and JMP Pro, there is a JMP Starter window that opens automatically on a Mac, or you can request it on a Windows machine. And there's a new button, JMP Pro, under Category. So this will describe the platforms that are unique to JMP Pro, and also JMP Pro features that are integrated throughout the standard platforms. Many campuses already have a license, a campus license of JMP Pro. And there are many other options for obtaining JMP if you're with universities or with commercial organizations. Academically, if you would like to get your own copy or explore these options, there is a link, jump.com/getjump, and this will describe those options. So we will be recording this webinar, and I will make this journal and all of the data sets that are used throughout the webinar available. This will be posted within a day or so, so you'll have access to this journal afterwards. This webinar will be more or less a survey of features in JMP Pro for teaching predictive modeling, and I'll try to point out the highlights. So I do want to point out that there are a lot of resources for teaching predictive modeling that are available. Under the Help menu, so this is the Help menu at the top of your screen, there's a really nice book, Predictive and Specialized Modeling. In fact, all of our documentation is found under the Books option from the Help menu. So predictive and specialized modeling, but you'll also see multivariate methods for things like dimension reduction, basic analysis and graphing, and essential graphing, and we'll talk about some of the tools that are covered in these books as we're going along through the webinar. We've also posted a lot of content at jump.com/teach, jump.com/teach. So these are our academic resources. So if you're brand new to JMP, there are a lot of things that we won't talk about. There's a nice set of getting started videos. We also have another series of webinars coming up throughout the spring, and every spring and fall we host live academic webinars. And we record these webinars and post the journals and data sets in our academic webinar library. In the course material library, we've also collected content that can be used to teach a variety of subjects. So if I scroll down, there is a course content or course collection for predictive modeling. So if you're new to predictive modeling and new to analytics, there are a lot of features here that you can use to either learn the concepts or to integrate into a classroom. So for example, short one-page guides and videos, these are from our learning library. There's a series of case studies. And what we've done here is we've compiled the case studies and the content that's particularly relevant to teaching predictive modeling. As you scroll down the list, there's also a number of books available. So there's Building Better Models with JMP Pro, which is a case study-based approach to teaching the core concepts of analytics. Data Mining for Business Analytics with JMP Pro. This is a new book that came out over the summer. There's a new release of Fundamentals of Predictive Analytics, and this is a SAS Press book. So there are a lot of really nice resources to help with learning the concepts and also teaching directly in JMP. So with that, let's go ahead and get started, and I'll tuck this away in the background. So what is predictive modeling? For the purposes of this webinar, we'll define predictive modeling as using past data and predictive algorithms to determine what will happen next. So this is essentially predictive analytics. So there's descriptive analytics and prescriptive analytics, and we'll focus on the predictive piece of this. It's guided by a process, and there are a number of processes that have been defined for this. So SEMA, developed by SAS, sample, explore, modify, model, assess, The CRISP DM is another process that guides the activities of data mining and analytics. And in the Building Better Models book, we define the business analytics process. So essentially all these processes have stages or steps where we define the problem, we compile data, we prepare the data for modeling, we apply the appropriate modeling techniques or algorithms, we deploy the model, and then this loop continues or the cycle continues. For the purpose of this webinar, we'll briefly talk about tools in JMP Pro for preparing data for modeling and for compiling data. We'll talk about modeling. In fact, this is where we'll spend most of our time in the core modeling tools. And we'll also see some new tools in JMP Pro 13 for deploying the model. So from the perspective of data preparation, we provided a webinar in the fall, data preparation and modeling, and there's about 30 minutes of coverage and examples of tools for preparing data for modeling from the perspective of analytics and predictive modeling. So just for a high-level overview of some of these features, and again, these links in the journals, the journal are available to you, so I'll make this journal available. For compiling and structuring data, there's a really nice data import feature. There's a query builder that makes it really easy to write SQL code and connect to databases and pull data in. We are integrated with SAS, so we can pull in SAS data. There's a new feature in JMP 13, the JMP Query Builder, and what this allows you to do is query from JMP data tables. And then also a lot of tools for restructuring data and a virtual join for, again, for joining data tables directly within JMP. There are a lot of tools for data exploration, and many of our webinars are specifically focused on data visualization and exploration. We'll see these three features throughout this webinar. Deriving new variables are new features. They're built-in tools for transforming data. Under the columns menu, there's a nice feature for recoding data. This is particularly nice for categorical data that may be messy. Making a binning formula, so if we have continuous data that we'd like to bin into buckets, there's a nice utility for this. And there's a really nice version of a binner on our JMP community. So our JMP community is community.jmp.com. This is where you can ask questions, and you can also find add-ins and data tables and examples that our users have posted. You can easily address missing values. So in JMP Pro, there's a nice tool for exploring missing values. Informative missing is a feature that's built into a lot of the modeling platforms for directly integrating missing value and the information directly into our models. You can address outliers. There are a lot of built-in tools for reducing dimensionality. And of particular importance here is creating holdout sets. So there's a really nice tool in JMP Pro for creating a validation column, and there are lots of options for doing this. And we'll see this as we go along. So from the perspective of predictive modeling, I put some links here for some nice data sets. The top two, these are data sets that are found in the sample data directory. So under Help, Sample Data, and if you just want a listing of files, the sample data library has a listing of files. The sample data directory groups them into categories. So from this this view, under examples for teaching, we see some really nice examples. So Titanic Passengers is really nice for teaching classification models. There's a body fat data set that's available under exploratory modeling, I believe. Maybe multivariate analysis. Let's see where this one is. Somewhere in there. The body fat data is really nice for talking about multiple regression and predictive modeling where the response is continuous. The two data sets we'll use throughout this webinar, Property Assessment Brighton. This is based on some data that were downloaded from cityofboston.gov, and we'll focus on a subset of this data. It forms a nice alternative to the Boston housing data. So this is current data, and we'll dig into a subset of this data. And then the German credit case data. And this is data from the UC Irvine website, and I'm using a version of this data that was compiled by a colleague of mine. So for the tools that we'll cover, We'll focus on fitting models. So the fit model platform in JMP can be used to fit standard least squares models, logistic models, includes stepwise regression, which is also model averaging and all possible models. And we'll see some tools in fit model for exploring a model in simulations. We'll see recursive partitioning. So we'll see how to build a classification tree, a regression tree, and a Bootstrap Forest and boosted tree. We'll talk about neural networks. And the Generalized Regression platform in JMP Pro is a modern it's a modern approach to generalized linear modeling where you can specify different response distributions. And you can also apply penalized regression procedures. So we'll see how to use this. And throughout these case studies, we'll use built-in model cross-validation features. We'll see how to compare competing models. And we'll also see in JMP 13, there's this new formula depot. And what the formula depot allows us to do is easily collect all of our models, compare those models, and then write out code to deploy those models. So it's a really nice new feature. We'll briefly talk about Text Explorer. And I do want to point out that there are a lot of other features that are related to predictive modeling that we won't have an opportunity to cover here. So things like naive Bayes and k-nearest neighbors, and a lot of tools down here for marketing analytics that are built right into the software. So let's go ahead and get started with the case study. So I'm going to start with this property assessment Brighton data. And these data, again, were downloaded from the cityofboston.gov. And it represents all single-family homes in the Boston area at the end of 2014. So the data were downloaded early 2015. So there's over 25,000 homes that are represented in the data set. And I've done a little bit of cleanup. So on this side, recall if you're new to JMP, all the columns are listed under the columns panel. There are some original variables that I'm hiding here. So this little mask says that I'm hiding these variables so that I'm not looking at them. And there's some other variables like zip code that won't be included in the analysis. And I've done a little initial cleanup. So the predictors are all grouped here, but I've done a little bit of cleanup. This is work that would have been done in the preparation stage. So let's take a look at the data. And a nice view of these data, since we have latitude and longitude, is to take a look at a geographic map of the data. So we'll go to Graph Builder, and this is a really nice starting point to look at any data. We've got latitude and longitude, and I'll just drag those variables on, and we get a map. And I'll remove the spline. And since these are geographic data, I'll right-click and go to go to Graph, and ask for a background map. And JMP is connected to a street map service. So I'll select this option, but you can also pull in background images. I'll just use this to get a feel for the distribution of these properties, and I'll click Done. So we can see that there are properties throughout Boston. If you're familiar with Boston at all, here's the airport. This is the harbor. And let's go ahead and add neighborhoods. I'm going to turn the control panel back on. And to make it easier to see the neighborhoods, I'm going to color by neighborhood. So coloring by neighborhood gives us a legend on the side, and as I click through, we can see where each of the neighborhoods are located. So here's Boston, here's Brighton, and Brighton kind of stands off by itself, Charleston, Dorchester, East Boston. Now, if you're teaching predictive modeling, these data are particularly nice because you can assign this as an exercise. So for example, in the book Data Mining for Business Analytics, one particular neighborhood is used. I think it's Roxbury, Mass. There are some webinars out there using East Boston. And for this exercise or this webinar, I'm going to focus in on Brighton. So Brighton is a neighborhood that stands off by itself. If you build models off of the different neighborhoods, you'll see that the different neighborhoods have different predictive models. So it's kind of nice for classroom use where you can assign different neighborhoods to different students as a capstone or a project, or work through exercises with different neighborhoods. So I'm going to go ahead and close this. In fact, I'm going to clear the coloring out here. And we're going to focus in on this particular neighborhood. So this is Brighton. So think of a case where We're looking at predicting what the home value will be based on different characteristics. I mean, maybe we want to build a web app or some other application to be able to predict the price of these homes. Now, to get a really nice first-hand view of the data from a numeric sense, under columns is this feature, Columns Viewer. So I like to look at Columns Viewer for my response and all the predictors. In fact, I'll go ahead and include latitude and longitude. And this will give us numeric summaries of all of the variables in the data set. So I'll ask for quartiles, and I'll select Show Summary. So this gives us a nice sneak peek at all the data. And we won't spend a lot of time on data preparation or data exploration here, but this is one of my favorite features. I'll hit Clear Select. So we can see the range of values for each of the continuous variables. We can also see the number of categories for each of the categorical variables. We see latitude and longitude down at the bottom. We can look at the mean versus the median to get an idea whether the data might be skewed. We can also look at the interquartile range. So this is looking at all of the data. But if I want to be able to subset and just look at data for a particular neighborhood, I'll go to Rows and ask for Data Filter. Now what the Data Filter allows us to do is stratify our data based on values of selected columns. So I want to look at neighborhood, and I specifically want to focus in on Brighton, Mass. So when I select Brighton, Mass, we see that there are 1,190 properties. I'll click Show, and this tells JMP to hide all of the other observations, and Include, which tells JMP to exclude all of the other observations from any analysis. Now I could just subset the properties for Brighton, but in this case I'm just going to use this data filter to do this for me. So let's look at the distribution of our response, which is total value, and we'll also look at a distribution of all the predictors. So this will give us a feel for how the response is distributed along with all of the predictors, and since all of the graphs are dynamically linked to every other graph, we can also look at potential relationships between the variables. So the variables in this data set, we've got gross area, the number of floors, the number of rooms, number of bedrooms, full baths, half baths, kitchen, fireplace. So a lot of characteristics of the properties themselves. But notice that there's nothing in this data set that relates to the location. So if we go back to that map, and here's a map just of Brighton, it looks like there are some clusters of homes. And it could be that location, so for example, some of these homes are along the Charles River. It could be that location is important in predicting price. So we may want to define a feature that includes this information in the model. If I look specifically at latitude and longitude, now all of these graphs are dynamically linked to every other graph. So if I zoom in on latitude and longitude, we can see that there are different general areas of properties. So how do I include this in the model? I don't want to use latitude and longitude in the model. Well, one approach is to define a feature using hierarchical clustering. So I'll go to Analyze. And by the way, all the multivariate procedures are grouped under multivariate. And there are several clustering algorithms. And we'll simply use hierarchical clustering. So I'll simply select latitude and longitude here and click OK. And I'll color by cluster. So the shorter the lines indicates that the properties are closer together. When we start getting longer lines, this indicates that the clusters are more dissimilar. So as I click and drag, in fact I'll click back in this graph to deselect values. As I click and drag, notice that it's grouping the homes into little clusters. And as I continue, you can see that they get more and more alike, and they get more different, but we're grouping these different neighborhoods together. And as I move it towards the left, we can see that we've got more and more different clusters. So I'll settle on maybe 5 or 6 clusters. And under the red triangle, if we save clusters, this creates a new column in the data table. And now this is a column that we can use for building predictive models. So we've already done that here. And notice I've got a validation column. So I fundamentally know that I want to do predictive modeling. To create a validation column in JMP, we'll go to Analyze, Predictive Modeling, and then Make Validation Column. So this allows us to create a column in the data table, and the way JMP uses this in JMP Pro is where it sees a training, the value training in the column. Training is used, that all the training data is used to build the model. Validation in some algorithms is used to stop model growth. And then the test set is held out, and this is used to give us an honest assessment of the performance of the model. So by default, JMP produces a 75-25 split, but we can change this. So for example, a 60-20-20 split. So 60% of our data will be used to train the model, 20% will be used to stop model growth, and then the last 20% will be used to test the model. There are different choices down below. If you're in a teaching situation, in JMP 13 we added the random seed here. So you may want to say, I want to set a random seed and give your students the same random seed and use fixed random. And this will ensure that all of your students have the exact same proportions in the holdout samples. But you can also stratify and do group random, and there's other options here. Now there are other tools that we might use for exploring these data, and I've saved some scripts to the data table just to expedite these. So for example, if I want to be able to explore the different variables, I can use a graph builder, and there's a tool called a column switcher that allows us to scroll through. So before modeling, there's a lot of work we do in exploring the data to look for potential relationships. We may also be interested, and I'll go ahead and run this again, in transforming variables. So for example, we may decide that we have a response that needs to be transformed. I'll go ahead and turn on the control panel. You can transform variables directly from any platform in JMP by right-clicking and then selecting the transformation. There are lots of different transformations that are available. You can also do this directly from the data table by right-clicking and selecting New Formula Column. Now the last thing we'll look at is multivariate. And I'm going a little fast here just to make sure we get to the modeling tools. Under Analyze, Multivariate, before we proceed with building any model, we might want to look at potential relationships between our x's and also between our x's or predictors and a response. So we can see that gross area looks to be correlated with total value, and there's a correlation matrix at the top. These density ellipses, the tighter they are, the stronger the correlation. We can see that some of the x's are also correlated. So for example, we would expect the number of rooms and the number of bedrooms to be correlated. We would also expect gross area and bedrooms and rooms to be correlated. So this gives us a sneak peek at some potential problems we might have. So for example, collinearity between our x's can cause us problems when we fit a linear model. So we're going to proceed as though everything's fine, and let's see how to fit a regression model. So I'll go to Analyze and Fit Model. And remember, we're only looking at a subset of these data where it says pick variables. Our y, our response, is total value. And when we select total value under personality, personality is a general family of types of analyses that we can run from this platform, from Fit Model. So Fit Model is the flexible, universal, general linear modeling platform. So fit least squares automatically is the default. Stepwise gives us stepwise regression, all possible models, and model averaging. Generalized regression I mentioned, and we'll come back to this. What this allows us to do is specify the response distribution. We've added a few features here in JMP 13, including quantile regression and Cox proportional hazards, but you see that there's also, if we had a categorical response, if we select binomial, this is equivalent to running logistic regression, and there's some zero inflated distributions as well. So I'll set this back to standard least squares. And other options here, if we have a categorical response, we'll see nominal logistic regression. There's also proportional hazards and survival and some other options. I'll select my x's. So I'll simply select the x's and click Add. And I'll point out that building style, roof type, these variables with this, the red bars, these are coded as nominal. The blue triangles, where you see the blue triangles, indicates that these variables are coded as continuous. JMP will automatically code the categorical variables for us, so there's no need to include dummy-coded variables in the model. And we'll see that JMP uses a -1 +1 effect coding system rather than the typical 0, 1 indicator coding, but I'll show you how to get the standard coding that's typically used. Now I've got a validation set, so I'm going to put validation here. And I want to make sure I include this clustering variable. So I'll select cluster and click add, and then click run model. So the first thing we see is the effects summary table. And this was added a release or two ago to give us a nice high-level view of the significance of the terms in our model. We see the summary of fit, the analysis of variance table, the parameter estimates for the terms in our model. I'll go ahead and tuck that away. The effects test, the p-values in the effects text table will match what you see in the effects summary table. We see the residuals by rows. So this is a standard residual plot. And then additional options are available under the red triangle. So for example, if we'd like to show the parameter estimates using standard 0, 1 coding scheme, then indicator parameterization estimates is the option we would use. Under effect screening, you see that a lot of options that are generally used more in a design of experiment setting. Under factor profiling are some nice tools to allow us to explore our model. There are different residual plots that we can request. And save columns allows us to save columns out to the data table for further analysis or exploration. So let's take a look at this model. So if I go to the top, it's sorting the terms in the model in descending order of p-value. And since we have a validation set, we see automatically some cross-validation statistics. So there's R² for the training, validation, and test set. And remember that the model is only being built here on the training set. RASE, think of this as root mean square error. So we'd like a higher measure for R². So a higher value says we've got better fit. RASE is a measure of error, so we'd like this to be as low as possible. And we also see the breakdown of our observations between the three sets. Now, as I remove each term from the model, this is equivalent to doing backward stepwise selection. All of the statistics automatically update. So as I click and hit remove, I'm slowly removing terms from the model, and I'm doing this a little bit fast for the sake of illustration. And then we come to our final model. And this is an overly simplistic model. I didn't include any interactions. But notice at the top, gross area, as expected, is the most important variable and most significant variable, followed by cluster. So if we didn't include cluster in the model, then all of the variation associated with cluster would be thrown into the error term. So cluster is definitely important here. Now some of the tools that we would use for exploring this model, again under save columns, we would generally look at studentized residuals or Cook's d-influence for influential values. So there's lots of diagnostic tools here. For visualizing the model and understanding the model, one of my favorite tools is factor profiling, and it's called the profiler. So what this does is allows us to interact with this linear model we've just built by changing the values of particular x's to see what happens to the predicted response. So at these values of each of the x's, the predicted response is $383,000, and in the brackets we see the confidence intervals for the response. As I click and drag a value, so for example, in this case I'm changing the value for gross area, we see how the response changes given the settings of the other factors. The slope of the line indicates what happens to the response as I change the values for a particular factor. So for example, cluster was very significant, and as I work through the clusters, notice the change in the average price. And again, given the settings of the other factors. Now from the red triangle here, there is an optimizer, so if you're in a situation where you want to find the optimal settings, you can do that. And in a case where you may have a lot of variables that show up as being significant, remember that the lines here represent the change in the response for a particular factor given the current settings of all the other factors. We may want to isolate out the effects of each of the terms in the model and also find out which of the terms are really most important. And you can do this through this option, Assess Variable Importance. And there are a few options here, and I'll simply select the first option, if we can assume that the variables are independent or not correlated. And what this will do is a simulation. And it's trying to isolate out the effect of each of the terms. So we can see that gross area really is most important when we consider all of the other variables, followed by full bath, building style, and notice clustering gets bumped down on the list. So we see a summary report, which is a summary of the most important terms in the model, and for this particular model, gross area really dominates. So this is multiple regression, and again we've gone through relatively quickly. Now a few features for talking about regression. You can also save the formula out to a data table. So if I save prediction formula, this saves the prediction formula out to the data table. And anywhere in JMP where you see a fat plus sign here next to the variable name, this allows you to see the formula. So we can see the intercept and the coefficient for each of the terms in the model. And this also allows us to see how JMP is handling the parameterization for each of the categorical variables. So here it's simply using a match, and for each particular category, we're simply adding or subtracting from the average based on that category. Now I'm going to go back to this model, and we may want to build a number of different predictive models and compare those models. So a new feature in JMP 13 Pro is the ability to publish a formula to what we call the formula depot. So where it says save columns, publish prediction formula, basically collects this formula and stores it in a depot. So this is independent of the data set. But what this allows us to do is we can look at different diagnostics here. So for example, if I go to the formula depot, we can compare different models, we can look at the profiler, we can ask for different statistics and model comparison. So this will give us the RASE and the average absolute error. And we'll see this at the end of this exercise. What it also allows us to do is score other data. So if I had another data set that I wanted to apply this model to, so if I had the same data in a different data set, or the same variables in a different data set with new data, I can say run script and it will score those new data. We can also generate code in a variety of different languages. So for example, if we know we want to build a web app, this generate JavaScript code will give us the code necessary to create that web app. If we want to do inline scoring, as the data become available, we might want to generate C code or Python code if we're using distributed computing, or SQL code or SAS code. So a really nice feature that allows us to take this model and deploy it to other data. So I'm going to tuck this away, and at the end of this demo then we will show the formula depot for a variety of models that have been saved. And let's talk about other tools for building predictive models. Under Analyze in Predictive Modeling, we see a lot of different tools. At the top, we see neural networks, then partition, Bootstrap Forest, boosted trees. These are all tree-based methods, along with k-nearest neighbors and naive Bayes. Model comparison allows us to compare competing models if we've stored the formulas in the data table. And you can also ask for the formula depot directly from here. So if you would like to open the formula depot and pull in formulas that are stored in a data table, you can launch it from the predictive modeling option. So let's look at partition trees. And I'll build a similar model with the same terms. So predictors, oops, let me do this over again. Let me hit remove. So a similar model with total value as the y, and my predictors as x. Again, I'll add clustering and validation. So since my response is continuous, JMP will fit a regression tree. If my response were categorical, JMP would fit a classification tree. So it'll default to the type of tree that makes sense. There are a couple of options here. Informative missing. This tells JMP to handle the missing values. And notice as you move your mouse over options in JMP, it gives you a description of what happens if that option is turned on. Ordinal restricts order is important if you've got ordinal variables. So for example, if I've got a variable that's coded as 1, 2, 3, 4, 5, it doesn't make sense to split the data where that category is 1 and 5 on one side and 2, 3, and 4 on the other. So this makes sure that JMP respects the fact that the 5 is larger than 1, for example. So I'm going to click OK here. And what a tree does, if you're new to decision trees, is it tries to find variables, and here we're fitting a regression tree. It's trying to find variables that are going to force the mean as far apart as possible. So it's going to find variables, and we're going to split on those variables at a specific cut point and divide our data into two subsets where the means of those subsets are as far apart as possible. And there are lots of really nice features here for teaching about trees. So for example, next to all rows is a red triangle, so you can force a particular split if there's things that you're interested in exploring. And under candidates, you can open up the candidates to see what JMP is doing to test where to make a split. So JMP is testing all possible ways of dividing the data into two subsets. So at the top we see gross area. This is continuous. So it essentially divides our data into two subsets based on a split point for every value of gross area. And it tests and finds the best split point for a particular variable. And since we're doing so many tests, instead of reporting the p-value, which is going to be, everything is going to be significant since we're doing all possible splits that we can possibly make, we report the log worth, which is related to the p-value. So it's splitting on gross area and number of floors, the number of rooms, and it's testing all of those splits for each of the variables. It tells us what the best cut point is. And of all these cut points, where you see this little asterisk, this is the term with the highest log worth, where we're getting the maximum distance between the means. And again, if you hold your mouse on top of any statistic, here it's showing us what the log worth is measuring. So if I click split, JMP produces two subsets of the data. The first subset has 666 observations, the second has 48. Again, it did this just on the training set. So it's splitting our data based on the values in the training set, and it's reporting R-square for the validation set and the test set, and also our MSE, or root mean square error. Now if I keep going, it continues to look through each of these nodes to try to find the next best split point, and the graph at the top is showing us the splits. So the black line is at the mean for gross area less than 4453, and this upper line is where we see the gross area is greater than or equal to 4453. And JMP will keep splitting our data in this fashion if we keep hitting the go button. Or sorry, if we keep hitting the split button. So I'm going to hit split again. The next split is at gross area again. And another split. And gross area is really, really significant here, so it continues to split on gross area. Now we can also automate this, and there's different ways to control tree growth. So in the red triangle, we can change the minimum split size, or we can click the go button. And what happens when we click the go button is that JMP continues to split, and under split history, it tracks the R-square for the training set, the validation set, and the test set. And this is really nice for talking about what would happen if we just kept splitting, kept splitting, kept splitting. The R-square for the training set continues to improve slightly with additional splits, but when we apply that model to the training or to the validation set, we see that it kind of levels off and then it drops down. And the same thing for the test set. So JMP will keep splitting. It'll find the maximum validation for the R-square. It'll keep splitting, and it splits 10 additional times, and then it drops back to the point where we had the maximum value of the R-square. Under the red triangle, again, you'll see a lot of different options for exploring the model. We've essentially built a logic statement. So the leaf report allows us to see the logic statements that have been produced along with the means for each of the branches or the nodes of the tree. Column contributions is nice. What this will do is it'll tell us the most important variables. So like we saw with the simulation and fit model, gross area here is really the most important variable out of all of them, followed by fireplace and then number of clusters. So that's a sneak peek at partition. Now another tree-based method that's really nice is called Bootstrap Forest. And what Bootstrap Forest does, and I'll just click recall here, what Bootstrap Forest does is that it's going to build a lot of little trees. So if I click OK here, you have a dialog, and the dialog allows you to specify how many trees. So we're going to build a lot of little trees that are really weak learners. And our final predictive model is going to be an average of all of those trees. It's going to bootstrap from our data. It's also going to randomly sample from the predictors that we've entered. So for each little tree, it's going to only randomly sample 3 predictors, and it's going to bootstrap sample from 100% of our data. So the resulting sample that the tree will be built on is the same size as our original data set, but it's going to sample with replacement. So it's going to be basically do resampling here. It allows us to specify how big the trees will be. And a nice way to teach this is to start with a really small tree, or a small forest. So if I build a forest with 3 trees, where these trees can be really small, and this is kind of a nice starting point. So start by looking at really, really small forest. By the way, there's other options here for getting much more complicated. So you may try a lot of different combinations of these tuning parameters. And in a teaching situation, you may want your students to get the same thing you do, so the bootstrapping and the random sampling of the terms will produce different results. To make sure you get the same results in Jump 13, set a random seed and make sure you turn on suppress multithreading. Okay. So if I click OK here, I've just built a Bootstrap Forest, and there's lots of statistics that are produced. I'm going to simply start by showing the trees, and I'll show the names of the trees. So my first tree here starts at full bath and then half bath and cluster. And remember, it's randomly sampling from the variables. And what's nice here, since gross area is so significant, this allows other variables to enter into the model. My second tree stops at gross area. My third tree starts at bedrooms and fireplace, rooms, and then gross area. Now my final model is simply going to be an average of these 3 models. And the way you can show this in a classroom is if you click on the red triangle and save the prediction formula out to the data table. And I'll go ahead and close this little window. And if we click on the plus sign next to, and this is our new model here, if we click on this plus sign, this takes us to the formula editor. And notice that we've got some if statements. Here's our first model, here's our second model, here's our third model. And if we slide over, notice that it's handling missing values. And if we slide over, we see that it's divided by 3. So it's simply taking these 3 models and averaging them together. And in reality, in a real modeling situation, we would build a very large forest. Now what the next option does, boosted tree, is it also starts with a small tree. And I'll just hit recall to pull in the same options. But it'll start with one small tree, a very weak learner, and it'll calculate the standardized error, or standardized measure of the error left over after fitting that tree, and it'll fit a tree to that, and it'll fit a tree to that, and it keeps on going. So we call these layers. So instead of building a forest, we're actually building a layer, one small tree on top of another. Again, you've got other options here, the splits per tree, how quickly it converges, the minimum split size. And we've added in Jump 13 this stochastic gradient boosting. So what stochastic boosting does is it also allows us to randomly sample from our data and also randomly sample from the variables. And if you use either of these options under stochastic boosting, and in the classroom, if you want your students to get the same results, again, make sure you set the random seed and turn on suppress multithreading. And boosted tree and bootstrap forest tend to do very well relative to other types of models because they're allowing other terms an opportunity to fit the model or to enter into the model. Okay, so that's a quick sneak at tree-based methods. Another important tool is neural networks. And in neural networks, I'll go ahead and fit the same kind of model and ask for validation. Make sure I get cluster in there. So I'm fitting the same model every time, and I'm using the same validation set. There's an option here in the corner to make sure that informative missing, so we've included informative missing in the classification trees or the tree-based methods. Sorry, we were fitting regression trees. By turning this on, it makes sure that missing values are included in the model. So I'll click OK here. Neural networks in JMP Pro allow you to fit up to 2 layers with 3 different activation functions. And then you can specify the number of nodes for each of those layers. Tan H is a sigmoidal shape function. Linear, this is equivalent to doing linear regression. And Gaussian essentially follows the normal curve. There's some additional options here for boosting. So similar to what we saw with the boosted trees. And then you can also ask for things like transforming covariates. If you've got outliers, robust fit is an option. And you can fit multiple models and take multiple tours through the data. If I simply click Go here, you'll see that it produces training, validation, and test statistics. And to get a sneak peek of what the model is doing, these are highly parameterized models. So I'd like to start by looking at the diagram for this model. So basically, we've built a model where, let me make this a little bit wider here. There we go. Where we have a lot of predictors, and we've got one hidden layer. The hidden layer has 3 nodes, and the activation function that we selected was the default, the tan H or sigmoidal shape function. So this little curve tells us what type of function we fit. And essentially, we're feeding each of these inputs into the hidden layer, the nodes of the hidden layer, where a transformation has taken place. And our final prediction is a linear combination of the output from each of these layers, or from each of these nodes. So it's a highly parameterized model, and there are some features that allow you to talk about how parameterized it actually is. So for example, if we ask for show estimates, we see all of the parameter estimates that went into this model. And this is really a very simple model, but we see all the terms associated with the first node, and the second, and then the third. So imagine how big this gets if we add additional layers or additional nodes. And these are the estimates for the output layer. So this is what's used to make the final prediction. You can also save this out to the data table. So if we ask for save formulas, if you're trying to work with your students so they understand what's going on behind the scenes, it'll save out the formulas for the hidden layers, so you'll see all the parameter estimates there, and then for the final predicted value. So the final prediction here is just a linear combination of the output from all of the hidden layers, from all the hidden layer nodes. And the last thing I'll talk about from the perspective of this example is generalized regression. So generalized regression, again, is from fit model, and if I hit recall, it's a personality from fit model where you can specify the response distribution. If you've got sensor data, you can specify the sensor code. I'll simply click Run here. And in Jump 13, it'll automatically produce standard least squares output if the response is continuous. If the response is categorical, it'll fit a logistic model. And there are different types of models we can run from here. So under this model launch dialog, standard least squares, forward selection, lasso, elastic net ridge. So these are the lasso down through double lasso are all penalized methods. And if we entered interactions into the model, we can also fit a 2-stage forward selection. So if we start with forward selection, and we've got a validation column, and I'll click Go, what this does is it starts, and I'll just drag the solution path, starts with no terms in the model, and these lines represent the values of the parameter estimates. So if I click on this first line, as I scroll down, we can see that there's nothing in the model, and as I move, I'm adding a term to the model, and it changes the parameter estimates down below. So as I keep going, we can see the values of the parameter estimates change as additional terms are entered into the model. And you can scroll through and you can see the values of all these different parameter estimates. It's adding terms to the model, and on the side, it's keeping track of the scaled negative log likelihood for the training set and the validation set. And it stops at a point where it finds the minimum value of the scaled negative log likelihood for the validation set. And we can really see that if we go here versus this point right here, these values are really pretty similar. There's not a lot of difference. These parameter estimates, this is a really nice way of showing when you've overfit your model. You'll see these lines really start to fan out. And to really illustrate concepts like collinearity, you can ask for diagnostic plots. So for example, if we're looking at plot actual by predicted, or plot residual by predicted, and we tuck away parameter estimates, as I click and drag this line, if I drag it to the low end, notice what happens to the residuals for the validation and then the test set. And we really see changes in these when we've got an underfit model or an overfit model. So they're really nice built-in tools under the red triangle to allow you to explore the models. And a big change in 13 was that we added a lot of different statistics here for model comparison. All right, so we fit a whole bunch of models, and I've actually gone ahead and done this, and I've stored all of these models in the Formula Depot. And so I'm going to go ahead and run all of these, and it's doing this. And the Formula Depot, again, is a nice place to collect all of your models and then to compare results. So here I fit a bunch of different models. And let's give it a second here. So I fit a least squares regression model. I fit a partition tree, so a regression tree, a Bootstrap Forest, a boosted tree, and the scripts for these are all found in the Formula Depot. Okay. And then in the red triangle, I simply ask for model comparison. Now to make sure we compare these models on the test set, under the red triangle in model comparison, there's an option for the local data filter. So I've asked for a local data filter, and I'm simply looking at the test set. So we see the R-square, the RASE, which again is similar to the root mean square error, and the average absolute error. I fit a few different generalized platforms, and I've even put in interactions. And we can see out of all of these that this two-stage forward selection, which is really ideal in cases where you have more parameter estimates than you do observations, this is actually the best model. So we see it has the highest R-square, the lowest RASE, and the lowest average absolute error. Now for this model, again, if we choose to deploy this, under the red triangle, we can write out code, or we can use it to score new data. So this was an example with a continuous response, and we're kind of running short on time. So I'm going to quickly go to the example with a categorical response, or target variable. I'm going to make all of these data sets available, and the scripts on the side allow you to follow the workflow basically that I'm following in this webinar. So this is a case where a response is categorical, and we see a breakdown of good risk versus bad risk. And in this particular example, again, this is from the UC Irvine Machine Learning Repository, and it's also posted all over the web. In this particular case, we have a situation where we'd like to maximize profit. So this is a bank that's trying to do a better job of identifying good risk versus bad risk customers. If you right-click on a column and go to column information, you can include information on cost in what we call a profit matrix. So for this example, since we're running out of time, I'm simply going to point out some of the highlights. So within column information, there are some properties that we specified. The data came in as 0, 1. So we've used value labels to make sure we see text rather than the numbers. By default, JMP will model the probability of 0, and you can use value ordering, again under column properties, to change the ordering. And where it says profit matrix, this allows you to either change the cutoff for classification. So if you have a rare event, so let's say we have really highly unbalanced data, then you can change the probability threshold for the target variable. You can also plug in a profit matrix. So the scenario here is that if the customer was actually a good risk, and we predict that they're a good risk, this is worth 35 cents on the dollar. However, if we predict that they're a good risk, but they're not a good risk, then we lose the entire value of the loan. And we didn't put anything here under not good risk, so we're not capturing the lost opportunity cost, but this is something you might consider. Now JMP is going to include this information when you go to model comparison or fit depot to allow you, or formula depot, to allow you to compare competing models. So I can do the same sort of exploration that I did with a continuous response, and I'm going to use these scripts just to expedite things. For logistic fit, in fact, let me go back to the model dialog. We made a couple of changes for logistic regression in JMP 13, And one of the things we did was we added this option to select the target level. So from here, rather than setting the value within the column properties, you can specify what your target level is. Another change that we made was that under the red triangle, you can ask for that same 0, 1 coding for the parameter estimates. So again, JMP uses the -1 +1 effect coding. If you'd like to see the 0, 1 effect coding or indicator coding instead, select indicator parameterization estimates. Since we fit a logistic model, there are all sorts of options that are appropriate. For example, ROC curve and lift curve. Again, we see the effect summary table that allows us to remove terms from the model. And the prediction profiler. And in this case, the prediction profiler, and this is an option in the red triangle, this allows us to see what happens to the probability that someone will be a good risk as we change values of each individual X. I already ran variable importance, the same thing I did with the continuous response, and we can see that checking account's most important, followed by amount. Okay, so there's some variables that stand out here. We can also run a decision tree, so this would be a classification tree, Bootstrap Forest, boosted tree, several different generalized regression options here. And if I compare these competing models, and again, I'm doing the same thing I did before. So I went to Formula Depot and I published all of these prediction formulas, and I selected the model comparison, and then used the local data filter just to zoom in on the test set. And for this particular example, we've got a situation where we might want to minimize the misclassification rate, but we've entered in a profit matrix. So if I scroll down and look at the model with the lowest misclassification rate, I might come to different decisions than if I look at the highest profits. The model with the best profits here is this two-stage forward selection. So this is saying my average profit per customer will be 13 cents on the dollar. You'll see both a confusion matrix and a decision matrix. And it's interesting to compare this. So in our confusion matrix, we can see that we coded 149 of the observations as being good risk. When we apply the profit matrix, we're actually coding fewer of them as being good risk. So we're being a little bit more discerning in terms of who we're offering a loan to, but the overall average profits are higher. So we don't really have time to talk about text mining, but I want to quickly show you a very quick example. So Text Explorer is a new feature in JMP 13. It's available in JMP, but if you're in JMP Pro, you have some additional options. And I'll very quickly show you how you can access this. So this is just some sample data, pet survey. And if we go to Analyze and then Text Explorer, this allows you to select the column and control the number of words per phrase, number of phrases, characters per words. You can specify stemming, what to use for tokenizing. And then once we're in the platform, we'll automatically see a term and phrase list. And these are highly interactive. So this is a nice platform if you're dealing with unstructured text data. And let's say, for example, this is data on a survey of cats and dogs. We're not really interested in how many times that word appears. We can right-click and say, let's add those as a stop word, so they're not included. If we've got words that are very similar, we may want to apply stemming or recode them. So for example, bark and barking, we may say, let's call those the same thing. So this calls the recode feature from the columns menu. We may also want to include phrases. So if I add phrases, this adds them to the term list. And under the red triangle are lots of options for dealing with terms, for parsing. If you're in JMP Pro, you'll also see latent class analysis, which is for clustering documents, latent semantic analysis, which is similar to principal components analysis, topic analysis, which is essentially factor analysis, and a lot of other tools that allow you to save out your results, to use the results when building predictive models. So I think I have run out of time. I do want to point out that there is an info kit on Text Explorer with a nice example if you're interested in digging into this further. And then there is a nice webcast or recorded video that was provided. So we focused there on tools for building predictive models using kind of some standard platforms. Keep in mind that there are a lot of other tools available for predictive models, for predictive modeling, and also for preparing your data for modeling.